Hey everybody, today we're going to be focusing on lab number 4, which is titled Cyclic Change and Sunspot Analysis. So we're going to talk a little bit about sunspots, what they are, how they're a cyclic phenomenon that happens on the sun. And then once we are done discussing a little bit about sunspots, I'm going to direct you to the lab. You should all find this lab as an attachment in your Microsoft Teams assignment. So you have this video, and then beneath it, you'll find the attachment, which is a editable PDF, I think, form file that you can do your answers in your lab on. Of course, if you are a hybrid student, you can always grab a copy of this in class if you're having a very difficult time printing it out. But by all means, definitely make sure that you click on the other tab to get the lab itself. So let's discuss sunspots. Sunspots is a very predictable and cyclic phenomenon which happens on the sun. And if you look at the picture that you see here, you can see that the surface of the sun looks like it has these dark spots or almost like freckles, if you will, which actually occur at a very cyclic and predictable rate. So I kind of wanted you to bring you down to the article beneath it. I want to read just a bit and explain to you what's going on with sunspots, and then I'm gonna, like I said, switch you over to the lab, which has to do with this. So this article, fairly recently, was printed up in National Geographic, and it says sunspots can now be predicted days in advance, and it says new technique may improve solar storm forecast, experts say. So it says sound waves from deep inside the sun can allow astronomers to predict the appearance of sunspots days in advance, possibly leading to better forecasts of hazardous solar storms, a new study says. Sunspots are regions on the sun's surface that are cooler than the surrounding areas and so appear darker, as you see the picture up here, right? The spots form due to intense magnetic activity and other magnetically driven solar events, such as flares or coronal mass ejections, tend to erupt from areas where sunspots appear. When solar flares and CMEs are aimed at Earth, they send clouds of charged particles from the sun racing to our planet. As these particles interact with our magnetic field, they create geomagnetic storms that can pose hazards to astronauts, spacecrafts in orbit, as well as to power grids and telecommunication equipment on the ground. Knowing when and where sunspots and any associated flares and CMEs will form may therefore be key to predicting solar storms. So in other words, the sun has these massive, almost like, if you think of like Earth's volcanic eruptions, it has these solar flares. It's almost like an eruption which lets off this intense amount of heat. And where the actual flare took place, you can see that once the flare stops being active, it ends up being a cooler spot on the surface of the sun, which ends up looking as this like little thing, this freckle, if you will, which we call a sunspot. And again, they're due to this magnetically driven energy which is happening within the sun. So the funny thing about sunspots is they are very predictable. Obviously, they can predict them days in advance. But what we find is that sunspots are a very cyclic event. Every about 10 and a half, 11 years or so, the sun actually has many, many of these spots. And over the next 10 to 11 years, they kind of trickle down and they come back again, so that another 11 years after the last like really high amount of sunspots, 11 years after that, you have another year of very high sunspots. So if we graph the amount of sunspots that we find in the sun yearly, we will find that you get peak years every 10 to 11, like it's about 10.5 years. Okay? So today, what we're actually going to be doing is we're going to take some data. Okay? We're going to actually go away from this for now. So let me just exit out of this. And we're going to actually take some data on a lab. And we are going to plot sunspots, the data, the number of sunspots for a bunch of years here. But before we get to the data, what I want to do is just make sure that we fill out the heading of the lab and we get our vocabulary really, well done. So if you would, hopefully once you're done watching this video, or maybe put this video on pause, what you want to do is you want to, excuse me, get a copy of your lab, okay, and we're going to fill out your name, the period, today's date, okay, and then we're going to start with the word event. So for event, okay, if we get a text box over here, let's move this guy up here. An event is when something has occurred. So something has occurred which changes the properties of matter. So again, you could slide this, maybe slide this text back over a little or maybe not, but it's basically when something has occurred which changes the properties of matter. Okay, so make sure you put that in for event, when something has occurred which changes the properties of matter. Okay, which brings us to the next actual vocabulary term. Our next vocabulary term, if we move our text box down, let's see if we can slide them down here. All right, we'll just put a new text box in. Here we go. Independent variable. The independent variable today is going to be listed on your x-axis. So you could just, oops, sorry about that, wrong place. You're going to type in x-axis, right? Get rid of this guy. And your actual x-axis in your lab is going to be labeled. So again, x-axis, it's going to be labeled as your time in years. So put that in there. So again, your independent variable will be on your x-axis. It will be your time in years. If you want to look up a further definition, like if you put this into dictionary.com, you can get, you know, a more lengthy definition. But the true definition of your independent variable is more or less like the variable which is unaffected. It's like the variable that whose variation doesn't depend on another variable. But again, today we're going to be plotting our independent variable on our x-axis, and it's going to be the time in years. Okay, so that brings us down to our next definition, which is going to be your dependent variable. So let's get another text box here and slide this guy down. And let's get rid of this guy. So your dependent variable today is going to be on your y-axis. So y-axis, and your dependent variable is going to be, specifically for this lab, your number of sunspots. Okay, so you want to put that in. A good definition, if you want something a little bit further for the dependent variable, is it's the variable whose variation depends on that of another. So again, the number of sunspots is going to be changing. It's the variable that changes, which is dependent on the year. Okay, so that's your dependent variable. Okay, that brings us to the word predictable. So let's get down to predictable. Predictable is defined as something, so let's move this over just a little bit. Something let's spell that right, hold on. Something we know is going to occur before it does. So again, predictable, something we know that it's going to occur before it happens. Okay, it's like, you know it's going to happen. Okay, that brings us to cyclic. So let's get rid of that text box here. And we got the next one, which is cyclic. If you want to define cyclic correctly, I'd say it is something which repeats over and over. Okay, it's a repeating event. Okay, cyclic. So something which repeats over and over, which brings us to our last term, the fanciest term, if you will, on this vocabulary, which is the word extrapolate. And extrapolate typically means to extend your thoughts based on data. So to extend your knowledge, if you will, of something based on data. Okay, it's to take what you know already, look at data, and try to extend what you think is going to occur. So to extend your thoughts on something based on some really scientific data. Okay, so here we go, our procedure. Very straightforward. It says using the data given, you are going to plot the number of sunspots from 1950 to 2004 on the graph. So you can clearly see you have years. Okay, when you get to the end of this column, you continue, of course, in the next column. Okay, and again, you got the number of years, and I'm sorry, I should say you have the year, and then you have the number of sunspots. So when we go to our graph, okay, if we kind of just continue on to our last page, which is our graph. The graph has been beautifully set up for you. There's nothing crazy here. You got the years starting with 1950 going across your x-axis. This is your independent variable. And then your dependent variable is your number of sunspots, again, which has been labeled for you. And you are going to plot. And if you see, you want to plot every single line, not just the ones that are labeled here, so 1950, 1951. If you plot correctly, you are going to see a very cyclic pattern emerge, okay? Once you are done, okay, what you are going to do is you are going to use your graphed information and your knowledge of sunspots, and you're going to apply that to the questions. Again, describe the pattern shown on the graph. You will see it's an up and down pattern, which we call cyclic. Which quantity on the graph is the dependent? Go to your y-axis. Tell me how your y-axis is labeled. It's either going to be the number of sunspots or your time. You have to go and look at your y-axis of your graph. Each peak on the graph you constructed represents a sunspot maxima. You want to list the years that are a maxima. Guys, the years that are maxima, you can look on the peaks on the graph, but you can also look at the data. So for example, like 1958, this is a maximum year because you can see on either side, 1957 and 59, there are lower numbers. So 1958 would be a maximum. And if I run my finger down to the next, okay, and come here, and 1968 is another maximum because again, the years before and after are both lower than that. And if I keep running my finger through the data, it goes down again and then it comes up. Let's see, 155, 146, yep, that's another maximum in 1979. So there's a total of, I believe, 5 maximum years. You want to list those maximum years. Again, those will be the peaks on your charts, but you want to list those maximum years in here, okay? Then it says calculate the average number of years that occurred between maximum. So if you think about this, it's like 1958, I think, was one. 1968 was your second. 1979 was your third. 1990 was your fourth. And 2000 was your next, right? So again, if you think about those maximum years and you calculate, you want to do an average. Well, you're going to figure out, okay, if I enter a text box in here, I'll probably make it a little bit clearer to you. But what you're going to do is you're going to take the amount of years, so between one maximum and the next. So again, this one was 1958, this one was 1968. So your first amount of years between 1958 and 1968 would be 10, right? Then what you're going to do is you're going to find out your next, okay, amount of years between 1968 and 78, which would be 11, right? And then the next thing that you're going to do is you're going to find out the amount of years between 1979 and 1990. And that's another 11 years. And then you go from 1990, the next maximum, to 2000, which should be in here. And that's going to be another 10 years. And to find an average, what you do is you add these all up, and then you're going to divide by a total of 4. So you would do 10 plus 11 plus 11 plus 10. And again, when you want to do an average, you just divide by the amount of things you added. Okay? Number 5, when did the last maximum occur? Again, that would be this number in here that you should have written in. Number 6, using your answers to questions number 4 and 5, predict when the next maxima occur. So if you look at the last maxima here, 2000, and you add the average amount of years for maximum, which is about 10 and a half or so, you would add that to your last maximum, and it will tell you when the next maxima peak of sunspots would occur in this data. And then last but not least, you need to circle the correct answer for number 7. Okay, read the statement. Number 8, list 4 natural events that could be considered cyclic. If you need good ideas, you want to go back to my video, which was posted on, basically, it was the nature of change. I believe I posted it earlier this week for your Microsoft Teams assignment, and I had you rewatch it a second day in a row. And then last but not least, you want to circle the correct answer for the sentence below. So I think this should be pretty straightforward stuff. Again, you may need to pause this video as you complete the actual lab itself. Please, of course, remember that you on your data are plotting every year. You don't want to just plot like, the ones that are listed here. You're going to do every single dot for every year and connect the dots as you go. If you try to connect the dots after you've plotted them, you may connect them out of order. Your graph won't be correct. And of course, that will lead you to having to redo things, and that's annoying. So you don't want to do that to yourself. So guys, again, lab number 4, hopefully this is a pretty straightforward lab. I hope you enjoyed that, and definitely tune in, and we'll touch base with you guys soon. All right, take it easy.